need
Yeah,
you to
yeah.
be quiet, but you're paying attention, all right?
Yeah.
And you can go watch it a million times tonight.
Hear all of our voices in the background. It's constantly
Hopefully I don't
screaming.
screw up. All right, ready? 1, 2, 3.
Action.
All right, so today I want to work a couple of examples for you of solving systems of equations using the elimination method. So these first four are set up to be kind of the easiest type where either the coefficient of the x terms or the coefficients of the y terms are already the same yet opposite. So we'll just start with number 1. So you see here the y coefficient on top is 2 and on the bottom equation is -2. So those can be eliminated right off the bat. And what we'll do is just add those two rows together. So I like to put a big addition sign out there because we know that positive 2y plus negative 2y equals 0. That will be eliminated. Now we need to add the x terms. 2x plus 4x is 6x. And 16 plus -10 is 6. So we are left with the equation 6x equals 6, only one variable, so now we can solve for x. Divide each side by 6, and x equals 1. So that's half of our solution. We have the x-coordinate of the solution to this system of equations. We can find the y-coordinate by substituting that x value or plugging that x value back into either of the two original equations. I'm going to go with the top one since everything's positive there. So I have 2x plus 2y equals 16. So there's the top equation, right? 2x plus 2y equals 16. But I'm going to replace this x with 1 that we got in the first part. So I pop 1 in there, and 2 times 1 is 2, plus 2y equals 16. And then we just go through the normal steps of solving an equation. We will subtract 2 from each side. And we have 2y equals 14. Final step, divide both sides by 2. And y equals 7. So the overall solution to this system of equations at number 1 is 1, 7. All right, second type. So what we have on these four is that our coefficients are not opposite, they're exactly the same. And you have two options here. You can subtract the two equations. Sometimes I recommend that we don't do that because when we have to subtract negatives, sometimes we make a mistake. And the method I'm going to recommend to you kind of sets you up nicely for the next level of difficulty of problems. So what we can do is we can multiply one of the rows by -1. And I'm going to start with number 6 this time. So I see the x coordinates, the x coefficients rather here are exactly the same. I need them to be opposite to be able to add them up and get one to be eliminated. So I'm just going to multiply the top row by -1. All right, now the bottom row is going to stay as it is, so I'll write my new top row right below it to kind of put together with that one. So we have -1 times 5x, which gives us positive 5x. And then we distribute the -1 over to the -7y, which gives us positive 7y. And then we distribute the -1 all the way to the other side there to the 9, which gives us -9. Don't forget about that constant on the other side of the equal sign. So now I'm looking at the original bottom row with the new top row, and I see that the coefficients of the x term are opposite. Therefore, I can add them up and they will be eliminated. All right? -5x plus 5x is gone. 5y plus 7y is 12y. And -15 plus -9 is -24. All right, divide both sides by 12. And I end up with y equals -2. So there is half of our solution to this system of equations. The y coordinate is -2. You know, if you remember back to the first example, we got the x-coordinate first, I think. So it doesn't matter which one you get first, it just kind of depends on which one is easier to eliminate first. All right, so I'm going to plug this y value back into one of my equations. It can be the originals, it can be the one that we changed up. I'm going to go with the one that we changed up since I see more positive numbers there. So I have 5x plus 7y equals -9. All right, I'm going to replace the y there with -2 that we got from the first step. So we have 5x minus 14 equals -9. Add 14 to each side. So I have 5x being equal to 5 now. Divide each side by 5, and x equals 1. So there's the solution to the system of number 6. 1, -2. All right, now I do want to do number 5. I can tell by looking that's going to be one of the special cases, and we haven't covered one of those yet. So let's look at number 5. We would go through the same process that we started number 6 with. I need to multiply one of those rows by -1. But watch what happens when we multiply the top row by -1. -1 times 9x, -9x. -1 times 2y, -2y. -1 times -26, +26. So I created some opposite coefficients here. I'm ready to add the two rows together. What is 9x plus -9x? Nothing. What is 2y plus -2y? Nothing. What is -26 plus 26? Nothing. So in actuality, what we end up with is 0 on the left side equals 0 on the right side. And you might remember from solving systems by graphing, we either got one solution, no solution, or infinitely many solutions. Think back to semester 1, solving equations. When the variable terms dropped out and we got a true statement, our answer was all real numbers. So this is kind of a similar situation there. When the variables go out and we get a true statement, our answer will be infinitely many solutions, which we affectionately call IMS, infinitely many solutions. What's the other possibility in a case like this? If the variables went away and we ended up with a statement that was not true, we would get no solution. All right? Moving on. So in these 4 problems, we don't have the same coefficient. We don't have opposites right off the bat. So we're going to have to multiply one of the rows by some number, not -1 this time, that will create opposites for us. And we usually have two choices here. I could either multiply the top row by +9, which would make the x coefficients opposite, or I could multiply the top row by -7 to turn this into a +7y. But I think I'm going to stick with +9. So I multiply 9 times -x, and that gives me -9x. 9 times -y, that gives me -9y. And 9 times 6, which equals 54. All right, so I've created opposite coefficients here with the x term, so we're ready to add the two rows together. What is 9x plus -9x? Goodbye. What is -7y plus -9y? That is -16y. And -6 plus 54, also known as 54 minus 6, that is 48. So we'll divide each side of the resulting equation by -16. And we get that y equals -3. So we have half of our solution. How do we find the x-coordinate? We know. We substitute it back in. and work it through. I guess I'll go with the top equation this time. A couple of negatives there, you know, I don't love that, but that's okay. Smaller coefficients, so we'll make it work. So we have negative x minus our y value equals 6. Well, what was our y value? It was negative 3. So we have negative x. Now, when we subtract a negative, remember that turns into addition. Plus 3 equals 6. We need to get that 3 on the other side, so we will subtract 3 and subtract 3. So we have negative x equals positive 3, but we're not solving for negative x. We need to know what x is. So when we have a negative in front of our variable, remember it's like there's a negative 1 there. So we can divide both sides by negative 1. And we will get x equals negative 3. So negative 3 is the solution to the system of equations from number 9. All right, let's move on to our next degree of difficulty. In these 4 problems, we can't multiply just one row by a certain number to create opposite coefficients. We have to multiply both rows. In this type of problem, there are an infinite amount of possibilities to choose from, but there's always a best 1 or 2 options. So what I'm going to do is number 13. I'm going to make these both 35. I can make both y coefficients 40 or negative 40, which would be about the same level of difficulty as 35. But I'll just go with the x coordinates. So I'm going to multiply the top row by 7 and the bottom row by 5. Now, why would I do that? Let's see. 7 times negative 5x is negative 35x. 7 times 5y is 35y. And 7 times negative 5 is negative 35. Now let's move to the bottom row. And I distribute 5 to 7x, and that gives me 35x. So there is the reason that I chose the 2 numbers that I did. They were already opposite in sign, so I just needed to make the coefficients the same number. If we had done the y's, we would have had to multiply one of them by a negative, not just both positive. So this is maybe a shade easier. All right, distribute the 5 to the 8y. That gives us 40y, and distribute the 5 to the negative 8. That gives us negative 40. So we're ready to add the 2 rows and eliminate the x terms. All right, when we add 35y plus 40y, we get 75y. And when we add negative 35 to negative 40, we get negative 75. Divide both sides by 75. And y equals negative 1. So we have half of our solution. Let's find the other half. We're going to plug negative 1 into any of those equations. I guess I'm going to go with the bottom one this time, just since the variable I'm solving for, x, has a positive coefficient there. So we have 7x plus 8y equals negative 8. And what am I going to put there in place of the y? The negative 1 we just got from step 1. So I have 7x minus 8 equals negative 8. Add 8 to both sides. And the resulting equation is 7x equals 0. So I'll divide both sides by 7. And x equals 0. So the solution for number 13, 0, negative 1. All right, and the last group of problems here, they require a little bit of manipulating before we go through the steps for solving. So you see how on this one, there's the constant on the left side and y term and x term on the right, and they're flip-flop from how we usually see them. You know, we're kind of used to seeing the x term, the y term, equals the constant. And that's personally how I like to deal with them too. So we got to do a little bit of switching up to get them to look like that. So what I'm going to do with the first one I have negative 28 equals negative 8y minus 5x. So what I can do is really just flip the whole equation around. So I'm going to rewrite it as negative 8y minus 5x equals negative 28. So we just took that equation and flipped it over. Now the only other thing I need to do to make this look the way that I'm most comfortable with is switch the positions of the x and y terms. So the negative 5x is going to be first, the negative 8y is going to be second, and that's going to equal negative 28. So there's the first equation that we're going to deal with. All right, on equation number 2, it just requires one step to get this y term over onto this side. So I'll rewrite that here. Negative 12x equals 15y minus 42. So to get this y term off of the right side and over on the left, I'll subtract 15y on each side. So that would be negative 12x minus 15y equals negative 42. So now I have the two equations that I want to put together and solve as a system. All right, so I'm going to write them vertically above one another, and then we'll go through the steps like we just did. So I have negative 5x minus 8y equals negative 28. Negative 12x minus 15y equals negative 42. Okay, so I've got to turn either the x coefficients or the y coefficients into the same number. So I'm thinking, what I'm going through in my head is, all right, if I double this, I get 24. Can I multiply 5 by something to give me 24? No. If I triple it, I get 36. Can I multiply 5 by something to get 36? No. So it's looking like I'm going to have to basically multiply them by each other, turn them both into 60 if I wanted to eliminate the x terms. Looking at the y terms, so I see 15. If I double that, I get 30. I can't turn 8 into 30. Triple it, I get 45. I can't turn 8 into 45. Quadruple it, I get 60. Can't turn 8 into 60. So I'm going to go back to the y terms and eliminate there. So what I'm going to do is multiply the top row by 12 and the bottom row by negative 5. See how they had the same sign to begin with? So I've got to change the sign of one of them. All right, so here we go. 12 times negative 5x is negative 60x. 12 times negative 8y is negative 96y. And 12 times negative 28 is going to be, let's see, negative 10 times 20 would be 200. 10 times 28 would be 280 rather. And then I need to add 56 to that. So that gives me 336. The bottom row, negative 5 times negative 12x. 60x. And negative 5 times negative 15y gives me positive 75y. And negative 5 times negative 42 is positive 210. Okay, so the x terms will be eliminated when we add both rows. Negative 90